Mary, I think you can start the recording.
I just did.
Great. It's 8 p.m. I'm going live on Facebook now. Once I'm clear with the live stream, I will say 3, 2, 1, and we're live, and then you can get started.
Okay.
Oh my goodness. What's up?
A down to earth sky guide.
A down-to-earth sky guy. Okay. Okay. And going live. Setting up webinar. Okay. 3, 2, 1, and we're live.
Good evening, everyone. Welcome to Amateur Astronomers Incorporated for our weekly Fridays at Home presentations. AAI makes its home at William Miller Sperry Observatory on the campus of Union County College in Cranford, New Jersey. But since the observatory is closed at this time, we're holding our weekly presentations online. Our presenter this evening is AAI member Kathy Vaccari. Kathy's been a member of AAI for several years. She's a qualified observer, meaning she can operate the 24-inch telescope at the observatory. She has given these presentations on the first Friday of each month to inform us of what you can see up in the night sky for that month. So the title of her presentation is What's Up, a Down-to-Earth Sky Guide. So with that, Kathy, please begin.
Thank you, Mary. September, yes, we are changing seasons, so there's a lot to look forward to. Here we go with the famous autumnal equinox coming around again. And you can see from this graphic, there's a lot of things, solstice and equinox, to describe seasons. And what always helps me keep track of the whole business is that in March and September, we have the spring and the autumn equinox. That equal part of the word tells us that we have an equal day and equal night and kind of a midland weather, which also helps, which we all look forward to, be it spring or autumn. So at this point, the Earth's rotational axis is neither tilted away from nor towards the sun. It's those direct beams that give us heat and very hot winter. I don't know if you can see the right side of the screen that says September. I tried to actually put most things on the left side because I realize on Zoom, sometimes the right side is taken up with the pictures of the speaker and or some other people who are there. But it is September 22nd at 9:30 a.m. if I remember correctly. Okay, here we go. A little GIF here. You have the fall and the spring equinoxes where the little orange circle is right in the middle. Okay, so it gives you the idea that the sun's rays are directly hitting the Earth at the equator for the fall, and the spring solstice. So it just helps to identify what we're talking about a little more. I will let that slide speak for itself, but let's continue on with 2020. Anyway, we've got a lot of planets. We've got Venus, Jupiter, Saturn, Mars. We've been able to see, well, Venus is a very, very early morning planet, and we've been seeing Jupiter and Saturn for the past few months, and Mars now is actually going to get to the point where it's coming into our, prime time viewing, which can be anywhere from 7 to 11 when we're at the observatory. But good evening sights. And the good thing about September and the coming months is that we don't mind, us amateur astronomers or astronomers of any other kind, that it's getting darker earlier. It just means that there's more time to enjoy the sky, and also things that we haven't been able to see till maybe 9:30, we'll be able to see a little earlier in the evening. Now, Venus, as I said, is a morning star. Here's a nice graphic from astronomy.com. This is an hour before sunrise. You're looking east, and you can see that it's kind of bordered by Gemini on the top and Leo constellation on the bottom. They're both pretty bright constellations, but the fact that it's charming in mid-September that Venus is right next to a crescent moon, it just makes for a very beautiful sight. And Venus is so bright, it's got that starburst look, not just a dot, like a bright star would look like most of the time. There's no mistaking it. There is nothing as bright as Venus except the moon and the sun in the daytime. So enjoy. Here's another graphic. It shows, again, mid-September, just before sunrise. There's a crescent moon. Now, the interesting thing about Venus is that we see Venus in phases, like the moon, okay? Just because of where it is situated. Venus is between us and the sun. And here gives you an idea that of the phases of Venus, and the year goes about 1.5 Earth years. So this cycle of phases happens over quite a long period. But the thing is, we never quite get a full Venus. And I have actually tried to see it in a telescope, and I've been able to do it. But it just makes Venus a very wonderful subject. Jupiter here is the first planet we see. And here is a nice photo by one of our astrophotography members, Cliff Ashcraft. And as you can see, like a good astronomer, he shows us that the south part of the planet is up. What a lot of people already know is that when you see an image with the naked eye, when you look in a telescope, it inverts the image. So a lot of things you're seeing are upside down. So that is usually something I always like to identify when I show a planet. And when you look at something in an illustration, it's good that they always tell you about that. Also, just a few days ago, we got a fabulous look at what amateur astronomers can do. Remember, professionals, they're either working on a project and they have time limits, or they are checking out a specific area of the sky. Nobody but amateur astronomers the world over are looking all the time. Someone is looking somewhere at all times, and you can really catch things that the professionals don't. Here is Clyde Foster from South Africa. He was imaging Jupiter. This is obviously a non-color picture, and you can see the red spot that all of us are very familiar with, a storm that's been around for several hundred years, at least as far as we know. He also saw another spot, and of course we're calling it now Glidespot. But he phoned that in, and what was really charming about this situation is that a few days later, Juno, which is the spacecraft that is orbiting Jupiter, it took a picture in color. Well, you can see the red spot up there, of course, obviously, that we're familiar with, of the spot. And that was just a gorgeous chance to show off what he found. And as a matter of fact, it did find a few more storms down in the southern atmosphere. But it's cloud material. Whether some of these things are going to dissipate, how long they're going to last, this is something that makes planetary observations so interesting. And Jupiter is one of the best because it will sometimes have the spot look like it's smaller, like the great red spot, or it will lose and then have reappear the belts around it. So we just love Jupiter. This is a graphic of Juno, the spacecraft. A very interesting thing about that, it was launched in 2011. It arrived at Jupiter 2016. And there is what we call a Juno cam. There is a NASA Eyes interactive, I'm sorry, this is blocking. Very good, okay. It's an interactive program that requires a download. I'm trying to make sure you folks can see this. Let me see if I can get rid of, I think I can, okay. If I'm gonna stay on it a little longer so that you could copy down this URL address, but apparently you can see what Juno is seeing at any given point. It's sort of, catching it live. So that would be a marvelous thing to do, to catch real-time information as the Juno spacecraft is producing it. Not to forget the 4 Galilean moons of Jupiter. On the left, you can see what you usually see in a telescope. Usually you can see a little clearly, more clearly, the bands around the planet. But the 4 Galilean moons, in a matter of hours, any number of hours from small to a large amount, those satellites will go around Jupiter. And you can start looking at Jupiter in the beginning of the evening, and by the end, there will be some movement. I don't have the information on each of the moons, but again, that's another reason why Jupiter is so much fun. And if you don't have binoculars, and if you're wondering about the first thing that you should buy, I would definitely say get a decent pair of binoculars. They're so easy to use, and they're baby telescopes in that you can see a lot more through them and a lot more detail, great many more stars than you can with the naked eye. Okay, Saturn is another one of our favorite planets. This is a nice picture from July of the northern summer and the southern winter, and it looks like they got a little blue down there at the bottom from winter, which is kind of interesting, but it's a recent picture. Also, Mimas and Enceladus are 2 of the moons of Saturn. By the way, some of these are very easy to see. Titan is the largest moon, and it is usually viewable in a telescope. Jupiter and Saturn, between the 2 of them, have probably 120 moons. Those are smaller, but anyway, these are the big ones. You notice on the top, this is actually, it turns out to be the correct position of Saturn. The Hubble people and all the people down here getting credit for the image have made sure that it's right side up. Now up here, we've been able to get more and more information on the northern part of Saturn. Of course, it's known for the rings, but the thing is that the globe itself is so fascinating. And there's actually a hexagon here. And then within the hexagon, there is a fascinating vortex. There, I don't know if this is a little better view to see. By the way, when you look in your telescope, the one on the left is going to be what you see, but it's upside down. The northern hemisphere is supposed to be on top, and it is here. So just to let you know, the Cassini spacecraft has been able to show us an awful lot. Now, one of the things we were able to see is this, within the hexagon, this vortex, 200-mile-per-hour jet stream. And the other thing is that when Cassini arrived at Saturn in 2004, we knew the hexagon was there because the Voyager spacecrafts in the 70s had gone by. But we didn't really know all there was to know about a relatively new phenomenon of this vortex. 2014 is when we actually noticed it. The problem was, as you can see, Cassini ended in 2017. A lot of us remember when they just sent the spacecraft through the rings to really its end, its end inside the planet itself. Well, that was just time to start to even look at this fabulous image, because the planet takes 30 years, 30 Earth years to go around the sun. And for most of that time, when Cassini was up there, it was winter in the northern area and it was shadowed over. So around 2014, it began to be able to see all this stuff going on. Carolyn Porco, just showing you here, led the imaging science team, and they're really just still working on images now, and working, on what they've been able to do up till 2017. But that was a real problem. We didn't have much of a coming out of winter going into summer for the Northern Hemisphere. What a shame. The thing is, around 2013, we were actually able to see that this vortex was growing and growing and growing and growing, and even changing a little bit of color. As I said, we knew about the hexagon for about 38 years. That's going back to the Voyager spacecraft. So it'd be just wonderful to be able to get back up there. But again, when you have 7 years per season, that's a little difficult to work out the timing of a spacecraft visiting. Okay, now where are we going to see Jupiter and Saturn? Well, Sagittarius is a pretty well-known and kind of easy to see constellation, and they have both been there. Jupiter comes up first, coming up from the east and setting in the west, and then Saturn follows it. Jupiter, like Venus, is very hard to miss. It's got that starburst quality. Saturn is a marvelous sight, but it really looks like a dot in the way that most stars just look like a bright dot. Here, it's easy to see because these two things are the brightest things in that area of the sky. So if you have a good pair of binoculars or a telescope, being able to see Saturn, even in some of the basic telescopes, you do get the real shape with the rings. Mars is coming into age. It's in opposition, which I'll mention later, in October. So it's not the best month to see it, but it's awfully good. So from early September, it's rising about 9 p.m. And by the month's end, Mars will be up around 7:30 p.m. and it will be darker. So we'll get to see Mars for a little longer. Here's some graphics on here from earthsky.org. In the beginning of the month, which is what we're doing now, here's today. It just mentions that there is a moon up. We love the moon. We don't like it to wash out a lot of the sky, but you know, we do the best we can with it because we do love the moon. And it is right near Mars tomorrow night. By the way, people who love Uranus, and you can maybe get a good dot view in binoculars, but definitely with a telescope. I have never tried to see it myself, but in a telescope, it is a very specifically green dot. And I'm going to try tomorrow because I will know where it is, because it's just going to be above the moon and slightly to the left of Mars. Over here, there's another from the 6th showing you how close Mars is to the moon. As a matter of fact, if you were in South America, you would actually be getting an eclipse because it's really, there is an arc, a lot of you already know this, an arc going across the sky that mirrors the path of the sun and the moon most of the time, or we're not too often, a little off that arc. And actually the zodiac constellations are in that arc. And we'll talk about that a little bit later. But the thing is that very seldom does the moon go right by that arc. And actually, this is what it's doing tomorrow night, but not for us. But it just helps to learn what the ecliptic is and where the eclipse word came from and refers to. Here is a fabulous, just a few days ago, it's not in September, but we'll take August 31st from our friend Cliff, and he did Mars. He's very happy that the occasional dust storm that obliterates any feature of Mars is not going on now. The cool thing that I found out was that, again, I hope you're able to see what I've written here in the right. I've tried to make it as far down as possible. Someone asked Cliff, oh, it's really cool how you pointed out those features. I mean, we do know Schiaparelli crater, especially if we saw The Martian. And where is the new rover, Perseverance, going to land? And that just went up in August 2020. And you see where it is. And it's going to be 2021, if I can read my own graphic there. Yeah. It's going to be just slightly under this Syrtis Major feature. And there is the crater. And look at the delta. I mean, this is an amazing place. And this is certainly going to be one interesting rover mission to try to find on Mars. Mars oppositions. Opposition is really when we're between, when Mars is directly opposite the sun, we can see it all evening, and it is really the best time. October will be the best time to see Mars. The thing is that I was very intrigued by this graphic mentioning that Mars, like most orbits, it's not a circular orbit around the sun. It is an ellipse and more of an oval. And there's certain points where a body that is orbiting another body is closer and farther away. And it turns out that in the months leading up to opposition, you see Mars better and better. That's why you will see it the best in October, and then it will start to sort of decrease as the year goes on. You can see here, 2020, it's a pretty good size just for that. And then this doesn't actually show the rest of the year. What it does is shows you some of the following years when the largest that Mars is going to be is shown here. So actually, it's probably the smallest in 2027. You know, as far as we are being able to see it, you know, you hear those urban myths that Mars is going to be as big as the moon and blah, blah, blah. That doesn't really apply. But as you can see, we're very lucky to have a decent size view of Mars in 2020. And then it will come back, as you see, when it goes up to 2035, we're back up to the prime view in that year of Mars. And there are periods of about 15 to 17 years when the distancing recurs. Now, this is our autumn sky. We're not going to talk about all of them, but one of the missions for me of talking about the months is to try to make it as simple as possible and to decrease the idea of star chart panic. A lot of stars we talk about are ones you can see with the naked eye. They are the larger ones, as you can see on this globe. And we're lucky to have some very bright stars here, which are holdovers for the summer. But like I said, we have darkness earlier and earlier, and the constellations that make up what we call the summer triangle here are still very much in evidence. There's Lyra with its very bright star Vega, Cygnus with its bright star Deneb, and Aquila, which isn't very well known, with Altair, its bright star. But as I said, this helps you situate yourself around the sky. You'll notice down here, we've got our friends Saturn and Jupiter, and they are actually, although you can't see it very clearly, they are in between Capricorn here and Sagittarius here. Now notice something about this. The other planet that we're pointing out this month is Mars. Mars is in Pisces, okay? Now, remember what I told you about the arc that the sun and for some part, the moon follow across the sky at night. We're interested in the ecliptic because it can show us not only what you'll notice here, you see Capricorn, Aquarius, Pisces, Aries, and Taurus. I am actually kind of showing you where, if they showed the arc, it would be. These are all very well-known constellations. That is what gave the zodiac constellations their prominence, because they follow that arc. And as you can imagine, because of the way the solar system is built, that is where you're going to find your planets as well, okay? You're not going to find them up here by, you know, the Big Dipper or Cassiopeia. You're going to find them down here. Now, during the summer, and we've experienced this with the Sagittarius is very low in the sky, and the one that's really going into the west and we can't see anymore, Scorpius, those are very low to try to see in the sky. When the year goes on towards autumn and winter, it actually gets, instead of going like this, it actually gets higher. And you can see Capricorn, Aquarius, we're getting higher with Pisces, Aries, and Taurus. So the other planets that are coming up that we could see are very easy to see in the autumn, and especially the winter is the best. Now, just going back to these three, these are the first things you're going to see when it gets dark. They are the brightest things in the sky. Just very briefly, because we've already gone over them, Lyra has Vega, which is actually, actually was the star around which I assume someone on the planet around the star Vega was creating the messages coming in the movie Contact to Jodie Foster's character there. Cygnus over here is the swan, and it's known, the head is actually a set of two stars, Alberio, which is absolutely beautiful. As you can see, stars are different colors. This is gold and bluish, and with a good telescope, you can really make them out. That's a beautiful feature. Aquila is not very well known. The only thing about Altair I can offer is that it was the star around which the Forbidden Planet, the 1950s B movie or BA movie, was supposed to be orbiting. Okay. Over here, these are the constellations we're going to be dealing with tonight. Cepheus, we're also going to do Pegasus here, Andromeda, which kind of borrows a star from Pegasus, and the Galaxy. We hardly ever do Cepheus, not a well-known constellation. It does go back to Ptolemy. I mean, it was really very well respected. And this is the king of Ethiopia, not the area that we look at actually, but anyway, he was a descendant of Io, which is actually the name of one of the satellites of Jupiter. He was put in the night sky, and this is the form that the people matched the pattern of stars to the figure of their mythological stories. And actually, he's upside down. This happens a lot. Okay, pointing out one of his feet stretching out. Actually, this shows a little better. It's upside down, so you can't see. But this is the Ursa Miner. He actually has his foot on Polaris, the North Star of today. The interesting thing, first of all, that's where we get the phrase or the concept of Cepheid Variables, which are stars that are very radically pulsing stars. They change diameter and temperature all the time, and it actually has helped us to measure the distance, knowing their luminosity. It's involved, but just to let you know that the first Cepheid variable is from the constellation Cepheus. I did not know that. It's got 6 supergiants and 1 hypergiant. One of the, well, it's got a number of nebulas, the Witch's Nebula, the Elephant's Trunk Nebula here. It also has objects that, one of them has a diameter of almost 18 billion kilometers, which is amazing. It has some of the largest stars in the galaxy. Oops, sorry. It also has a quasar. And for those of us, you know, for beginners, I like to make things simple as possible. Quasar, if you think of it as a quasi-stellar radio source, you know, it's not really a star, it's not a planet, it emits radio waves, basically. It has one of the largest black holes that we know of, and that's about 10,000 times the size of the Milky Way black hole. You know, at last count, at least the Royal Astronomy Society of 2010 thought that was the largest one we've ever seen. But anyway, the actual Delta Cepheid, which is the star that is the which is the Cepheid variable, was discovered in 1784 by John Goodrich. But the character of Cepheid variables was really developed and, fully developed by, I love this name. I want this name in my next slide. Henrietta Swan Leavitt in 1908. Now, the actual constellation we're going to talk about next is Pegasus and Andromeda. There you go. In the back, I don't know if anyone, I assume people can see me. I actually have a picture here that I just noticed tonight of a marble horse. It was from the British Museum. I don't remember a lot more, but it's very fitting that I be sitting here with something I took several years ago with one of those, disposable cameras. So Pegasus is derived from the Greek. You see here that the folks putting patterns together, they're called asterisms to describe part of a constellation, but it is actually the top part of the horse. And as we have seen before, it's actually upside down in the sky when you see it. Okay, there you go. This is Pegasus. The great square of Pegasus, which has 4 stars that are recognizable with the naked eye, shares a corner star with the Andromeda Galaxy. This is elongated V shape. And the cool thing about that is that here above, really above these 2 stars that are kind of in the middle of the long V, you will be able to see the Andromeda Galaxy. I'm going to show you this a little more deeply. By the way, Andromeda was the daughter of Cepheus and Cassiopeia, and she got in trouble with, I believe it was Neptune, the god, because of her mother's vanity. But we'll go into her victimhood later. But she's not always a victim. I'll show you later. We have actually Rosamunde Pike playing her in Wrath of the Titans. But here you see, I usually go to, see this long V, I go to the corner star here, I go out to, because these are very bright stars. Then you go up one to a pretty bright star. You pass 2 stars straddling a middle here, and then you have this object that looks like a smudge. And the thing is, the fact that it's another galaxy is terribly thrilling. It doesn't matter that you're just seeing a smudge. But that's the way I like to view and get to view the Andromeda Galaxy. There you go. I want to give credit where credit is due. Here's the Andromeda Galaxy taken by one of our wonderful astrophotographers, Helder Jacinto of our group, and I have placed it in there. Also, we have another, Tolga Gamusayak has also taken a beautiful picture. Now this is 2.5 million light years away. Okay, now light years, as a lot of you know, are an easy way to describe incredibly vast distances. One might say astronomical numbers in astronomy. So 1 light year kind of figures to 6 trillion miles. That is the distance light can travel in a year going at this rate. So a light year is kind of a mixture of time and distance, and it certainly comes in handy when you're talking about enormous distances. By the way, what we view today is sometimes a time machine. The light from the Andromeda Galaxy started to come towards us 2.5 million years ago, when our ancestors, this is a good picture of Homo habilis, meaning handyman. That was around that time. I think we needed to go to the Homo erectus and then the Homo sapiens. But this is how far back it goes. So in a way, one of the mind-blowing things about astronomy is you could be looking at a star or a galaxy that isn't there anymore because we're seeing it as it looked 2.5 million years ago in the case of the Andromeda Galaxy. That is just absolutely marvelous. It's the farthest object we can see with the naked eye. A lot of things we see, like Betelgeuse, much closer. I think it's like 800 or so light years away. This is 2.5 million. It is the farthest thing we can see. You could see it with the naked eye and a very nice dark sky sight. Not going to happen here. The other thing that I'll go into more detail next month is it's hurtling towards our Milky Way for a collision at 250,000 miles per hour. And basically, that's the distance between us and the moon. So it's like traveling from here to the moon in an hour, and that's how fast it's moving. And here's a nice graphic. It's not going to happen for a few billion years, but we are on a collision course. We're just going to combine and make a nice new galaxy. That's kind of cool to think about. Now, we don't have any meteor showers. Whoops. We don't have any meteor showers for September, but the last thing is there is a comet that is pretty much right now, you know, it's a daytime thing. You really, unless you're really good at finding things in the daytime, but towards the end of the month, like we said, it will be, that area will be in darkness and you can try to see it. It's named after a woman named Howell, Ellen from Palomar. And because of the way the solar system is all set up, we can only get a good look at it every 11 years. So this is our year. So those of you who love hunting comets, this would be a good time to pounce. Okay, I just want to give you some acknowledgements on where I get some of my material. Our thanks to the AAI astrophotographers. And thank you very much for your attention.
Okay, Kathy, thank you very much. Does anybody have any questions for Kathy? You can put them in the Q&A pane at the bottom of your screen. And if not, okay, that's it. Thank you very much, Kathy. I just want to remind everybody you can join us every Friday night at 8 p.m. online. Next week, Aaron Zuckerman will be presenting. I don't have his title yet of his presentation, but he'll have one. He'll be ready for us. So please join us next week. And here's to clear skies and stay safe, everyone. Thank you.